Is there
starting.
anybody joining us?
I will let them in if anyone shows up, but we are officially up and running. And Dr. Lang, I will have your slides up here, and if you just let me know, because we are broadcasting
Yes.
for our
Okay.
folks later on. So the floor is yours.
Okay, yeah, thanks for the invitation, opportunity, talk about HMI. And I'm not gonna talk in detail about any standards because my feeling and my experience is that we have good standards, but they don't help you to really design the HMIs. So that's why I'm talking about the best practices and also what is the expectation in the control room so that you get a good HMI. Okay. So a little bit my background. I just mentioned that I grew up in Germany. Went to the University of Karlsruhe on the Rhine River. So I'm a chemical engineer, and I actually also have a bachelor degree from the U of M. I was here as a foreign exchange student, 82, 83, so a long time ago. But so I'm an alumni officially, and when I was here, the thing that was new to me was, it sounds crazy, but it was process control. Because in the German, at that time, it's different now. The curriculum didn't have process control and for chemical engineers. So anyway, so that's when I found my interest in process control. And I asked the professor here before I left, where can I do work in that area at the German university? And he said, go to Stuttgart. That's what I did after my diploma. I got the PhD in Stuttgart on modeling and control. And since then was always to a certain degree involved in that area. But I also have a lot of operations experience. And my first exposure to HMI was actually, I was a plant manager for Bayer in Leverkusen. And we did an upgrade for Foxborough system. And that's when I first got exposed to, okay, what do we need to do to get a better HMI? And so since then I had this interest, and then later I switched to the petrochemical side. I worked for Lyondell in Houston. And they gave me a task to look at, we call it operator effectiveness and human factors. And I will talk a little bit about that in my talk. So that's when I started to get deeply involved in the HMI, and I worked a few years as a consultant as well on HMI and on alarms, and then I went back into the manufacturing side. First for specialty chemical titanium dioxide, and later for Cargill here in the Twin Cities. So I'm not an automation guy per se. I'm more from the process guy, operations guy, but always with a focus on how we help operators using the technology to be better. Okay? So that gives you the big picture. Now go to the next one here. So this is what I mean by HMI. And if you look, you can see that, but it will tell you at the bottom right. This is a
Sorry
sorry.
Sorry about that.
Doesn't matter. It is actually a screenshot. So it's nothing old. It's an actual screenshot in a plant in the Midwest. So this is still HMI. It is not what we expect to be good HMI, but that's still in a lot of our plants here. We still have these HMIs.
Yeah, it's typical, right?
Yeah.
It's typical. Quick introduction or intersection. Is he speaking loudly enough for us to?
I think so. Yeah, I think we're good.
Okay.
Yeah,
Just wanted to ask.
I think we're good.
Yep. Thanks. Okay. So, and why is it not good? Any idea? I guess you know.
I think there's too much information.
Yeah, that's right. There's too much information. There's too many colors. And it doesn't really highlight what is wrong and what is running okay.
All on one layer.
Yeah, so it's not really helpful for the operators. So to the next slide, please. So a little bit of a history. On the top, I'm not sure who has seen those. I've seen those. These
Yeah.
control panels, which actually weren't that bad because they gave you a kind of a big picture view. But you only had a few measurements because of the single instrument panels there. And then we went to this in the middle to the DCS. Everybody got excited. We had so many opportunities to put all kind of information on the screens, and that was actually the bad thing. We overloaded the operators. And I call it a keyhole effect because it's kind of, if you look at through a keyhole in a door and you see just a little piece of what's going on and you lose the big picture. And that's when the high performance HMI discussion came in, where we went back and said we want to see the big picture, and we want also, of course, turn down them. But the big picture is the overview, and that's the new trend that we have good overviews, and that's pretty much high performance HMI. Okay, so to the next. Another history. So the whole discussion actually started with, you may have heard that abnormal situation management consortium started in the 90s when we had these big accidents, and so the shells and the Exxons and the BPs, and they started this together with Honeywell. At some point, Ian Nemo, I'm not sure if you know Ian Nemo, but he's one of the key HMI experts. He was leading that consortium, and he's a friend of mine, and he brought me into that discussion when I was at Lyondell, and I joined then the ISA 101 standard committee, worked on the ISA 101 standard, and was published in 2015. I also worked on the extension to the IEC standard, which is pretty much the same. It's nothing different. So that's the history part of it. And as I mentioned at the beginning, the next. So this is the only slide for showing the standard here. So the standard goes in detail on how it should look, how it should be done, how it should look like. One of the key things is we need to have 5.22 HMI philosophy. So each company should have an HMI philosophy. I can tell you when I joined Cargill in 2018, they did not have, and it's a big company, they did not have an HMI philosophy. So that's one key thing that each company should have, and then based on the philosophy, you have a style guide that defines how you want to show certain things, etc. And then depending on what specific DCS you're using, you may have several ones. You get the toolkit for each of your DCS systems. So anyway, this is the only page out of the standard I'm going to show. And the last line, that's important, one of the important things. Human factors engineering plays a huge role if you want to design it. Okay. So if you go to the next slide. So why human factors? That's something that people didn't fully appreciate. And I learned that at Lyondell specifically because a petrochemical plant has a huge focus on reliability. But when we looked at our reliability incidents, we said, okay, we need to not just look at breakdowns, we need to look at what caused the breakdowns. And that's when we saw, oh, there's a big influence of what our operators are doing. So that's the human factors influence. And so there's at least to a third, but maybe to 50% of the incidents and reliability are affected by human factors, safety, of course, and
Safety, absolutely.
and also a little bit environmental, but so that's a huge effort if you want to improve your reliability, your safety, work with the human factors. Yeah. Next. This is sorry, you have to click. So this is also an old slide. It's 25 years old in numbers, but it is nowadays probably double of the 10 billions. But the key thing is operational error is the biggest factor, and it's probably even bigger because many companies don't classify when they look at the process upsets what's caused by mechanical, what's caused by human factors. So if you would do more detailed breakdowns, I would guess it's even higher. So anyway, you can lose a lot of money if you're not designing your, which is HMI, it's a big part of it. And that's a discussion I keep having even now when I go to some consulting work with the plant managers. They always ask, okay, what is the value if I spend the money in improving my HMI? And then my question is, okay, can you tell me how much money you're losing because your operators make mistakes? And they usually can't, but then I ask them, look at what's happening in your plants and see how many times the operators just are making a wrong decision because your information is not conclusive that you provide them. It's not their fault. It's
Question,
yes.
in the colonial pipeline, intrusion and inability to capture the right data,
Mhm.
they just hit the big red switch and shut everything down. Of these, would you consider that an operational error?
Yes.
Okay.
Yeah.
I would too.
Yes.
Okay, or you on the same
Yeah.
page with you? Thank you.
So next slide, please. So when you look at these incidents, so alarm is a big issue. So I'm not talking about alarms, but also HMI. So the HMI did not support what the operator was supposed to do. It had all kind of data on it, but it didn't help the operator. And it had too much color on it that confused the operators, and sometimes it didn't even have the required information. So HMI played a huge part in these incidents. So next, please. And continuing this, there was this lack of overview. So usually then what happens is an operator gets an alarm and he starts drilling down and focuses on, I need to fix this. And he forgets what else is happening. And so that big picture was missing. And then also what we found is operators rarely use trends. And trends gives you also good information because it shows you how did you get there. And that may give you clues what's going on. Okay. Next. So I keep talking about situation awareness, which is pretty much you need to be always in sync what's going on in your process. And if you miss if you get out of sync, then you lose situation awareness, and then you just miss or potentially miss important stuff. So to address this, we need to think about how can we improve the situation awareness for the operators, which is focus here to the next one. So showing you some poor. So on the left side, you see too many screens. So what is a typical number of screens that an operator can handle? Can you guess? Two?
Two.
No, it's
Yeah,
more.
let me say two.
You say four.
Oh, four,
Yeah.
okay. A very small number.
Mhm.
You say four an operator can handle. But not eight or whatever. And another thing that is much better, getting better now, but in many control rooms, even in the 2000s, 2010s, everything was dark because of the displays. Yeah, so they had the dark displays and they had the glare, so everything's dark. But that's, of course, not good for the operators. It's strain on the eyes, that's one thing, but it makes you
Sleepy.
sleepy.
Yeah.
Okay, so. And then the last thing is that the way things is presented, engineers designed it using PNIDs, and that's what you get, okay? No, honestly, that's.
No human factors there, it's
Yes,
just
yeah,
pictures.
yeah, and I mentioned that when I was a plant manager in Germany, I had this task that we wanted to upgrade the Fox boom. And so I said, okay, I get my good operators and then I show them what Foxborough has provided as a starting point, and I asked them to check it and change. So they changed a few things, but they never thought outside of the PNID. They always, because that's what they were used to, so they had no other, let's say, suggestions, vision. And I, at the time, neither. I just changed a few things so that we had more information on a screen that was helping operators to see things. But I didn't have the expertise either. So pretty much my experiences later when I did myself the HMI work, before you hand the operators to make their changes on, you need to have an education session. Okay, so each 2-3 hours before you do that, you need to sit down and explain things like I'm explaining and explain what options do we actually have nowadays. And then you get really good ideas. But if you don't do this, they haven't seen anything else, so they're just going to repeat what they know, right? So that's an important thing to keep in mind. If you do this HMI work, you should spend some time initially to educate your operations guys. Okay.
We all know, I think, that data without context
Yeah, it doesn't mean anything.
doesn't mean anything,
Correct.
right? You have to put some context with the data or put the data in context. And then all of a sudden it becomes information.
Correct.
And so,
Yep, exactly.
good reminder there.
Good. So next one, please. So I'm going to continue with the Pro HMI design. So if you click, we got the PNID, we got no trends, we got flashing, spinning graphics. That people thought it's great, but it's actually not. So, and color coding of piping and vessel, color coding in the plan, that's fine, but not on the HMI screen.
Yeah.
Okay. Measurements in the unit of measurements in large bright text, which draws attention but doesn't tell you anything. Lots of crossing line is confusing. This I still see they're using alarm colors for other stuff, which you should know.
That's a confusion factor.
Yeah.
Yeah.
Okay, so and this source that's I want to highlight. This is a very good source. So the high performance HMI handbook.
Is that your book?
No,
No.
it's a book that came out 2014, right before the standard. The Nemo is a co-author with Gary mentioned,
Okay.
but that's a very helpful. And Bill Holyfield, there was also a member of the standard team. He's co-author. So it's a very good thing. So next. So I mentioned situational awareness, and at Lyondell, I created that program. We call it operator effectiveness, and we rolled it out to the globally for Lyondell. And we had 3 main contributors to increase operator effectiveness. I'm going to focus on the HMI. Just want to mention alarm, of course, is clear, but also control the performance. So if you go into a plant and you see that they have a lot of control loops in manual, that tells you that the operator effectiveness is not high, because the operator has to watch what the control loop should do, has to move valves manually because controls are not working. And that's a distraction, and then you cannot focus on what you want them to focus to avoid, upsets and to avoid big mistakes. So that's also an important aspect of this whole operator effectiveness. Just wanted to mention that. But back to the HMI, to the next. So there are certain, we call it demons of situation awareness. Oh, that was.
There we go.
So, no, you've.
Yeah, it's gone.
If you go back to the other slide. Yeah,
There we go.
so attention tunneling is what I mentioned. If you have something operated focus, you forget what else is going on. Memory trap is something when you have seen it before and you think that's the same thing, and so you just do it, and don't check.
So is that the same as just presuming? Presuming something is happening rather than being able to analyze
Yes,
what the screen isn't telling you?
correct. No, it kind of, because it happened before, probably several times, something similar.
Yeah.
And it's just, okay, I know what it is,
I know what it is.
and I
Okay.
don't look at the big picture.
False presumption, false assumption. Yeah, memory trap.
Yeah.
Okay.
So then you have the workload, anxiety, etc., fatigue, other things. Then the data overload, too much data. So, the next one is similar to what we call misplaced salience. That's the first picture. You have a lot of, things happening, a lot of colors, but
Yeah.
what is really important? No idea. It's just overwhelming. That's what we call misplaced salience. So you should only highlight things that are important and not these. Complexity creep, yeah, that's another thing. Too many features make it difficult. And then what we call the mental model, the errant mental model. So if somebody has a certain model of what's happening and that may be the wrong model, then of course he may do or she may do the wrong things. That's again why we should always have an overview picture available so that you can at least check easily that your mental model is not totally. Yep,
So this is it. The errant mental model occurs in the design phase of the HMI screens. Is that what I understand?
no, it can also be part of it, but I'm talking about the
The operator?
operator itself.
Okay. Oh, situation awareness.
Yeah.
Yes. Okay. Yeah.
Yeah.
Thank you. Thank you.
No, but it can happen in the design phase too. It's,
Yeah. Putting up the wrong kind of information or the
Yeah,
not insufficient information or
it's,
distracting information can help lead to that. Gotcha. Okay.
okay, and then the last thing, this is something that was brought up quite often by plant managers. That they say, okay, if we have too much automation, my guys don't know what's going on anymore. And that can undermine situation awareness. My answer to that is always, yes, if you don't train your operators, this is going to happen. It's your job to make sure that that they keep training your operators so that they know what to look for, and then it's not going to happen. So that's what you need to do. You have to so, for example, at Lyondell, what we did is that we had recertification of operators. So they got training, and then they had to recertify their position. If they failed, they couldn't be at the position. They had to get retrained and another certification. So it's on the operator operating company to make sure that the operators are trained, and then you don't have this issue with the automation, for causing the operators to lose touch with what's going on.
You should know where to look, like, this is the
Yeah.
status, we're currently in the process, this is how much of the process we've done, how much is left to go.
So then other factors that affected, of course, the organization. Like I said, the management has to be aware of what's important. They have to retrain, they have to reiterate to their team, etc. It's up to the individual, of course, as well. It's up to the environment in the control room, where we still, honestly, we still don't do a good job in many cases. But see, still now, if I go to control rooms, I scratch my head sometimes. Really, you expect your guys to have situational awareness in this kind of control room? Okay, and then of course the screen design as well. That's others. Next one. For the poor lighting, I talked about that already. The noise can play a role. If you're in a very noisy environment, with vibrations, that makes you tired, that makes you, distracts you. So poor ventilation, same thing, that makes you tired as well. Same as heat, cold, humidity. Distractions. So if you have your staff meetings in the same room where you operators do the control job, that's not a good thing, but I've seen that makes sense. Yeah. Any fatigue issues. Also, the placement of the windows plays a role. If you place the windows in such a way that you've got a lot of glare on your monitors, that doesn't help, right? And communications, yeah, that's also, if you get too much distraction with not a lot of radio traffic, that's also not helpful. Okay, so all this, and that's outlined also in the standard, that this needs to be also looked at. It's not giving you the details, but it raises that there are other factors that you need to look at. So, changing workforce is also something that what I'm seeing happening in the Midwest right now is they have a lot of turnover. What people, experienced senior guys come out, young guys, 3 years experience, and they don't have a proper training and transition plans.
No succession plan,
No succession plan.
no documentation of what the
Exactly.
experienced guys ran into,
Yep.
how they fixed it.
Correct.
Yeah, how they understood it.
Yep.
Between the various pieces of information that was never changed.
That's exactly, that's what I'm seeing. And the other thing is, if you look at the generation that's coming in, they're not used to this kind of displays.
No,
They work with this little smart
tiny screens.
tiny screens, and they can click, get whatever they need, and this is not the case here.
Yeah.
So.
Yeah, this is static.
Yeah.
And they're used to something that's more dynamic, right?
Yeah.
Yeah. Oh,
And so you lose kind of the attraction of younger people wanting to do the job, because it's totally outdated.
exactly.
So that's another motivation, that we should change it to make the job attractive for the young generation, so that we get young operators in. Similar thing is, you reduce the staff, and so the area of responsibility gets bigger for one operator. That again raises the importance of having the overviews, so that the operator has a chance to be in sync with this whole area of responsibility. Yeah. But the rest is also clear, but let's go to the next one. So this is an example of, it's in a plant in the Netherlands, but that's a typical compressor train. Does it tell you how this compressor train is running?
Telling you it's on and off, but it doesn't tell you how it's running.
Yeah, and so a simple change, this is just a simple change that we did, if you go to the next stage. Shows,
Oh, yeah.
okay, important are the levels and the pressures and the band where they should run. So you can see right away, this train is running, okay.
Yeah. Yeah,
So
it's within bounds, huh?
Yeah.
Yeah,
It's a simple
yeah,
change, but it's a huge improvement.
yes, yes. So you made that recommendation, huh?
Yeah, we made that it's only 20 years ago, but
Yeah, yeah. So just an example. Yeah. That's cool.
okay. So back to the question, how do we increase the situation awareness? So the first two I keep off because I mentioned it, but we provide what we call the high performance HMI now. So that's what we want. It's really a total change of focus, because the focus is now the operator, the person that is running the plant. So we design it for that person, and it's not an engineer somewhere looking at pre-IDs and designing it and maybe sticking to your color schemes and blah, 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 but that's still not high performance. Because if it's not addressing the operator's needs, it's not completed. Okay? So many people ask me, oh, you have to put in gray background and reduce the color and the clutter, and that's it. I said, no. That's-
Now, I would say both the screens you showed have their place, it's just they tell different things. The one with the overview doesn't tell you how well it's running. The second one definitely does.
Yeah.
Whereas the first one, as an overview, gives you a model of what's the physical layout. You know, it probably needs a little help because it's very busy. I think an operator probably would not look at that too often unless they wanted to locate where the fault was because an alarm happened, okay, where, and then it would give them some clue, but if they wanted to know, okay, the health of it and how it's been performing, that second one definitely gives you the trends that you're looking for.
Yeah, I'm not saying that you don't need the other ones. So there are situations when you really need to drill down and you need a very detailed.
My idea would be to have them side by side, so they could see what's on and off on this one, and this one has the trend.
No, that's what you want. Yeah, you want to have. So in an ideal world, you want to have what I call the level one. I will mention that later. The level one overview, which is the big picture, and covers the whole responsibility for that specific operator position. And if you do it well, you have it on a larger screen. It's always up. You never change that. And then you have your 4 detail screens, and that's where you run the process. But that big picture is always up and gives the operator the key big picture.
And that's only half of the screen that you can pay attention to.
Yeah, right.
One big one and then the one focus.
Yeah,
one.
correct.
Operational status.
Yeah. Let's see. Yeah, we can go to the next one. That's what we call user-centered design. It used to be more a technical centered design, and now it's a technology centered. Now we want it to be user-centered. And we in the discussion within our group for the standard, we emphasize this is not for an engineer, not for the designer, this is for the operator. This is our main customer. So that needs to be the focus of the design. The people who's running the plant. That's how you design it, okay? There's a good another standard, the ISO 11064, which talks about yeah, not how to design it, but how it should look like. So that's also a good standard for color schemes and blah, blah, blah.
And
Okay.
so all four of these bullets are from the book Designing for Situational Awareness and Approach to User-Centered
Yes.
Design?
Yeah,
Okay.
Yeah.
Thanks
Yeah.
for that reference.
yeah, that's also a good reference from Mika Ensley. Yeah, that's also a good one. Yeah. Okay. Now, this is how we think you should design. Okay, so gray backgrounds, low contrast.
I'm good.
Twitchy fingers.
So this is one that is an actual overview screen in one of the petrochemical plants. So this is a level 1 overview. It has a lot of status information on it. It has a lot of trends but only of key performance indicators. Okay, there's no process trend. These are key performance indicators.
Yeah, KPIs. Yeah.
KPIs, so that the operator sees where the process is drifting from an effectiveness perspective. Because that's what, in the end, it's what we wanted to focus. So we had this discussion, again, that was back at Lyondell, that we had these fancy model predictive controllers in place. And we were wondering why in the hell aren't operators not pushing the process? And it was simply because they got distracted and there was no indication that they're out of the optimal range. So we introduced this kind of KPIs, showed them on the overview screens, and then it started to slowly change because now it was obvious. Oh, this is what we need to watch. And this is what we need to drive to a certain range. And how can we do it? Oh, yeah, there's this NPC stuff. We have to work on this. So that's how we got the switch of the mindset, and people started to focus on using the overviews, putting the right KPIs there, and by that telling them, hey, this is what we want you to watch, okay? So what else? Limited use of color. So if there's color on the screen, that should tell an operator something is there I need to watch. Maybe it's an alarm, maybe it's a loop not in automatic, or maybe it's bypass that is currently active, whatever, but that's in color. Everything else is just the process is a normal shape, nothing to worry, okay? I think we did discuss the rest, yes.
Good person coming in.
Yeah, I'm just gonna let them in here real quick. Go.
Oh, there's Shauna. All right. She
All right.
made it.
You're back up.
All right.
Hi, sorry, I got caught at work, but I'm here. Gotta catch the tail end.
So these are some other fundamental considerations. I think I've touched on some of them already. So yeah, what are the key measures? That's the example I put. So giving that information to the operators. That's another thing. Yes, if you have dedicated startup modes or shutdown modes for a complex petrochemical plant, that's the case. Then you should have a separate overview for startup, for shutdown, and for normal operation, so that you again help the operators look at what's important for a specific situation.
Yeah, in the context that they're in, right? Yeah.
Sometimes you have alternate feeds and products that should also be indicated. If you have a different feedstock, that usually requires some changes in your process setup. If it's not obvious for an operator that this is now feedstock B instead of A, he might not catch things at all. Okay, so always, if things change significantly from your setup, make sure that this is obvious to the person that is running. So when you design, you sit down with operators, I mentioned this before, you do task analysis, and so make sure that the designer understands what the operator it needs to see, needs to do, and that's how you design again. Operator focused design. Good, I think that's pretty much. This is an example of HMI, high performance, limited use of color here. Only used for indicating either an alarm, the yellow, or a bypass, or the valve at the bottom. So otherwise, everything is subdued. And you see that there's not always a number. So you see this above the valves, you see that it's lighter, and you see that,
And the yellow he's talking about?
no, in general, yeah, it's thanks. I don't have my mouse, open, so, yeah, exactly this. So usually you would see a number there, but now we show that's where it is in the range that we want it to be. So it's
Yeah.
it's at the upper range, or it's at the lower range, or in the middle. So that's enough.
Yeah.
Okay,
They can investigate further
exactly.
if they want. They can
Yep.
dial up what's
Yep.
that part of the process and say, okay, what is the number?
Right.
Yeah. Oh, that's good. That's good.
Or other option is you can have a toggle saying, show me numbers, and then choose or whatever. But,
Nice.
so the next
Yeah, the
one.
young operators would ask for a pull down, right?
Yes.
Give a pull down.
Pull out, exactly. So this is on the left side that's how it should not be, but that's what you often have.
Yeah.
So you have this, I mean, this is just,
Burns your eyes.
it burns the eyes.
Yeah.
Then usually red is an alarm color anyway.
Right.
And then there's this other aspect of the color blindness, okay? Some people
Right.
wouldn't even see the difference. So what we say is just use this high, this different gray scales. So the dark one is stopped, the light one is running. So that's all. That's pretty straightforward. Do that consistently, then it's clear. So next example is alarms. So the top row shows a very bad design. It's just changing the color to the alarm of the number. So that's bad. Second, they have this color fill out the whole shape. That's also not what we want. It's better, but it's still not good. This is the same, but just putting around the color. But what we want is we want to have different indications, not just the color. So you see,
Yeah. Diamond.
you have a diamond or a triangle upside down, and so that is an indication. If somebody's colorblind and he sees it, oh, this is the shape. Okay. And you can also then have the number. Number gives you 1 is the highest priority, 2, 3, and 4. If you have 4, and this other one is a suppressed alarm, the one that's that with the S inside there. So this is what we suggest people should do with the alarming. Different color shapes, maybe even a priority number.
Yeah.
Next example is, that's what you mentioned also before, is a number. Doesn't really tell you what's going on. But if you give it context, then it's information. And then it says, okay, I'm in the limits, I'm in the middle of the range, I'm really good, so I don't have to worry. Same with the output, which is the below. So it's the output is where the transition is from the dark to the light gray. So you see, my output is in a range where I don't worry because I'm not close to the limits. That's what I know. Done. So that's the good way. Not the top. The topic is not the good way because it doesn't tell you anything. Next example. So on the left level indication, you saw that on the first example that I showed you from this year. Still have this kind of level indication. This is very poor. It's better to at least give the limits in the middle, right, where your alarm limits are and where you actually are. Even better is if you keep the trend in the same environment, because then you can see, oh, I'm trending really upwards now quickly, so I may have to do something. So the right hand side is the best way of doing it. So here is another example. Here is only numbers. You see, that's all it. The experienced operators, they know the numbers, but younger, unexperienced, they have no clue. That's why again, in the next slide, you have the indication that I mentioned before. So you see, I'm in the middle of where I should be. I'm fine. So this is just a different way, but now it's information because you're showing the range where you should run, where you are. Okay. So on the display levels, so we speak about having 4 display levels: 1, level 2, level 3, level 4. What is the overview, the big picture? 2 is also kind of an overview. I'm showing example. The thing is, it shows the overview of a specific section, not the whole area of responsibility. And the expectation is that with a level 2 overview, 90% of your actions and control are done from those level 2s. You don't need to go to the details for most of your tasks. Only if you really have to do troubleshooting, you go to 3. And 4 is pretty much your alarm screens and very specific diagnostic screens is level 4. And you want to be able to, at the most, 2 strokes to get to every one point to every other point. Okay, so like I mentioned, level 1 is the overview displays, and it shows the whole area of responsibility. It doesn't show you all the alarms, it only shows you the top 2 priorities of the alarms. That's important for the overview. It has the high-level key performance indicators, like I mentioned, gives you the major equipment status information, and it shows you any abnormal situation that is developing. And then you can have several level 2s that you drill down from level 1. Like I said, level 1 always stays up. That's why we say it covers the whole area of responsibility of that one operator position. So it stays up, and then you can work with the level 2s to run your process sections or drill down further. Okay, so that's the philosophy. Level 1 always up, never take off. Next one. This is just this is what I showed to one of the first overviews to one of to the operators. Very basic to tell them this is how it should look like. You have a trend. The trends can have several scales and with colors, but they always are designed so that they should, in the normal range, run in the middle of the trend and not at the edges. To the left, you see some alarms, some status indicators. Then you have the trend, and you see T is the temperature, B is the valve. So it gives you the basic sensor characteristic, and it shows you if it's trending up with the arrow, if it has an alarm, if it's getting close to the edge, it gets darker in the gray. If it's out of the known range, it's dark black. So this is kind of giving you some ideas what you can do. And that's how I started to train the operators. Next one gives you one that is similar to what I showed before. That's pretty easy. Operators initially get a little bit nervous, but once they get used to it, they use it. So the one at the bottom is this
The radar?
The radar. is actually, the radar. We used it and it was accepted by the operators. So
They liked it, huh?
yeah,
Yeah.
I was skeptical myself, but no, so it gives me a good idea. And if it's distorted, I know something is wrong. So it was accepted. It was, yeah, okay. Another one. Yeah, sorry, the alarms, I was gonna say.
Yes, right.
Upper right, the alarms, it doesn't tell you the details, it just tells you how many in each severity. But they are acknowledged and acknowledged, yes. Okay. So this is another way of designing an overview, which I actually like that too. We have this is done by a company, Lin and Associates, I'm not sure if you know those.
Who?
Lin and Associates.
Yes, well, then associates, yes, yeah.
They're doing really good design work. And so what their philosophy is, I show that it's difficult to see right now, but they have different symbols for different temperatures, flows, pressure, blood. So you see from far whether it's a pressure or a temperature that is going off. Everything is lined out normally in the center. And if it goes off center, you have to pay attention. And if it goes yellow, you have an alarm like this one. And on the top, that's a high priority alarm happening here. This is a low priority 2 alarm happening. So this is a good overview as well. And from my experience, that was very well accepted by operators. This kind. And it's good that's why I put it. It's good for the long distance viewing because, like I said, these are overviews that are sometimes a little in the back. So operators sit in front of their little screens and then listen back. But this kind of gives them a good chance, even in the back, to see what's going on.
It's easy to focus on that.
Yeah.
If you have to go from a close screen to a back screen,
Right.
yeah, it's easy to see. It's comfortable.
So I think now it's level 2. So like I said, this is for a specific section, one line or one event train. And it's for normal operation, or you have one for startup, or you have one for shutdown. So these are different ones. It's not even the same. All important controllers and indicators are on that for that section. All alarms for that sections would show there. You should try to kind of give the operator also a picture about the material balance, where it's important, but it's not always, but where it's important.
Yeah, the process. Yeah.
Yeah. And like I said, most of the process should be run using that level 2. So only, like I said, 90% of the actions can be covered by just this one. And then you have drill downs to the level 3 to the detail. So you just click on that unit operation and you get the 3, and you can review the troubleshoot when it's necessary. Okay. I'm not talking about level 3 because that's what everybody knows. So I really wanted to focus on the level 2.
That's the one everybody's seeing right now.
Yes.
It's the too busy one. Too much detail for normal.
Yeah.
One of the things that I have noticed when I go to control rooms is just how, it's not that the screens, the HMIs are busy by themselves, but there are a number of alarms that are going on at any one time.
Yeah.
And it is just like one.
Yeah, that's-
After the other. And as a lay person looking at that, and they're just going about their business like it's routine. And I guess that's just the norm, but,
No,
you
no,
know,
no.
I see errors, failures, this, that. I see a lot of blinking things. Is that common? And so.
But it shouldn't be common, but unfortunately, it's still common.
Those are the ones that Jonathan.
I wasn't down. I wasn't down in Baton Rouge, and that's what.
Wow, a Dow, huh?
Yes.
Wow.
Yeah, I'm not surprised. I've been in, like I said, when I was working, we had bats in Louisiana too. And if you don't make the effort, like I said, we had to start this operator effectiveness program. And we started with alarms, because that's the most obvious things, and this is what always comes up as a first in this incident investigation. Operator missed this alarm, this, and then things happen. So alarms need to be addressed, but this is not what I focus here, but
Yeah.
alarms need to be addressed.
Alarm management.
Alarm management.
Yeah,
that's the
it has to
thing.
be addressed.
Has to be addressed.
Yeah, and reevaluated. What should be maybe a warning? Like if you're gonna ignore it, it seems like it's
I-
a warning.
I see that, you know, people are very comfortable in their alarms, and, I mean, I could see that.
Yeah.
No, the thing is that they are not comfortable. They're ignoring them.
They're ignoring the.
No, that's what's happening. They're ignoring the alarms because they're useless.
Yeah.
There are so many that they can't work with it, so the operator. They just have to ignore them, otherwise they could do their job. So, but that's exactly when things go bad, because then they miss. That among those 100, there's one that's important.
One critical.
Yeah, and that's when things happen.
Yeah, they're making their own decisions as to what is critical.
Right.
I mean, they made a choice as to what to ignore.
Sounds like
And-
a
and then-
Chernobyl accident to a certain extent.
Yeah. And what so this one plan that I showed you, the picture from 2026, they had the same, on alarms, operators had totally ignoring alarms because they were just flying. Okay, so what did management do? They created a new set of now important alarms.
Critical alarms.
Uh,
We just had that tomorrow. Yes.
Yeah, exactly.
It didn't help, okay, so they caught a few things now, but the thing is, do proper alarm management
Yes.
to address it. And then, in plans where we did the proper alarm management, guess what came up next? HMI, because then operators were happy with the alarms, and then they said, but hey, this information is not really there, and can you put this? So then the HMI came into focus, and we had to, well, we did all the redesigns. So we started first with alarms, but then the HMI came into focus right after that, and we had to fix both.
For
So
operations, yeah.
operations, yeah.
Yeah.
So they play together. That's why I had it under the operator effectiveness, if you remember, alarms and HMI, they play really together to make operators' life good and comfortable, and nothing's gonna happen in the plan. Seriously.
Do you see trending used in alarms?
In alarms, no.
No. I would wonder if some level of trending would provide some, you know, system level.
No, the thing is, the trending is used by operators.
Yes, yes.
But in a good way, an operator would use the trend to avoid the alarms, because they see, oh, it's
Yeah.
trending in the
Yeah.
direction of
I
the
see what you
alarm.
mean.
I
Yeah,
take action before the alarm happens.
yeah, gotcha.
But maybe there's too many things happening, and then the alarm comes up because there was just too many things. That's why you need the alarm, but expectation is, I have trends for the operators.
Yeah.
They see I'm going.
Yeah.
Towards the, you
Yeah.
know, out of.
Things are escalating.
Take action.
Yeah.
But you still need the last because everybody misses something sometimes, and that's not.
Is this your last slide?
The second but last.
Okay, why don't we finish that and then we can continue
Yeah,
some
uh,
discussion.
Yes.
Yeah, it's, the payback is, okay, we have less plant upsets. We recover really faster from plant. It's difficult to prove, of course, but we try to prove it in Lyndale again. We had simulators, okay? We used simulators with with the old HMI and with the new HMI, and you could really see that operators were recovering quicker than the new ones. So we had data to prove it, but I mean, usually it's difficult to prove, but it is actually true. Yeah, better focus on key process indicators and faster completion of tasks. And then the last slide. Oh, no, so it's one more. I wanted to mention that is in most plants, you still have this operator philosophy of alarms tell me I have to do something.
Yeah, the alarm is to do something,
Yeah.
I agree.
And what we try to instill into the operators is, no, we want a proactive operator. Like what I described, we want to really watch what's going
Mental
on,
model, right?
have a model, look at the trends.
Yeah.
Take action before you have the alarm. So it's a total change of the operating philosophy. It's behind, if you do good HMI, change the operating philosophy, then you see the benefits.
Sure.
And that's the last slide, and so these are wins that we had seen. So quicker startups, we saw that with quicker startups. They're repeatable, and of course, if you have automated startups with sequencing, that helps us, of course, as well. Yeah, significant less errors, significant less overshoots, fewer trips due to operator errors, improved focus, enhanced ability to respond to many different situations, positive HSE impact, and
And you mean health, safety and environment?
yes, health safety money, that's right.
Yeah.
Yeah. And reliability went up.
That was the goal.
That's the goal.
Reliability.
There's significant benefit in investing in good HMI. It is still a battle to convince management, unfortunately, I have to say that, to spend the money, but it is really money good spent, or well spent. Okay, that's basically,
So that's your last slide.
that's the story I wanted to tell you.
Great presentation.
Excellent.
Thank you.
You're welcome.
Are you still consulting?
Uh, if you want me to do some hourly work, I'm happy to do so, but I'm not, as I said, I'm a freelancer right now.
Oh, you're free. You don't have to pay for it?
No, you have to pay for it.
You're free from any other commitments. is what I
Exactly,
hear.
yes.
Okay.
This has more to do with the format here. You didn't have a microphone. I could hear you, but I wonder if the people who are joining online can hear you.
I don't know.
The microphone's right in front of him.
Yeah.
So
We
he's
can,
literally,
we can hear you pretty well.
he's a lot closer. to the
Yeah,
microphone.
that's what I wanted to ask is
Yeah.
somebody online tell me if they get,
Yeah.
they
Yep.
hear. Okay.
Excellent.
Well, all right, so I have
Yep,
a.
we can, yeah, we can hear beautifully.
So much of what I'm seeing now, especially with the younger generation, is they want remote accessibility via things like this.
Yeah.
So, I go into plants now and I see people with tablets.
Yep.
That have accessibility to the HMI and, or sometimes even cell phones.
Yep.
That have cloud accessibility.
Sometimes, yes, I've seen that too, yes.
Yeah, and I'm wondering if if there's any thought process to HMI design for the fact that more and more people may be looking at it on a device that it wasn't originally designed for.
That's a good question
Because
because,
like web pages
Yeah,
do
yeah,
that, right?
yeah.
Web pages conform to the form factor that you're viewing them on versus the
we
original.
had
tab.
this discussion actually in a standard committee 2 years ago. Because we say the design is for the operator. But we may have to think about having a design also for the support engineer. So that on the tablet, the information that person needs is tailored to that specific needs. That would be a different design. And I think there's a need for that, but I'm not sure if it's already addressed, but definitely a good point, yes.
I certainly don't think they get the same display
No,
as the operator.
Like right now, you know, for our water tanks that we have in the lab down there, I can pull that up on my phone right now. It's almost impossible to interrogate any of the buttons that were designed for a big, you know, 50-inch screen,
right.
you know, on my phone. I mean, because the targets are so small, you know, so.
And of course,
Something that's some important number for somebody walking by with a display on their phone, but not the whole picture.
and of course, you have to always keep the security in mind.
Yes.
Definitely.
That's a key thing. Don't forget that part.
You only,
Yeah. So,
I worked for wastewater at one point, and that's what a lot of them wanted. They wanted to have phone access through VNC. They wanted to have Windows tablets, and the tablets made sense because they would be walking around the grounds and like, you know, it's pretty spread out, you know. But every time someone was going into that, you know, remote viewer, it instantly alerted security. You get a phone call pretty quick, like,
yeah,
who are
okay.
you? What are you
Yes,
doing?
yeah. Well, that's very important. Don't neglect the security. That's key. And of course, the other thing is you should not allow it's strictly read only.
Yes,
It's only,
especially if you can.
yeah,
lock down
only,
any
it's only,
controls.
only one way direction. Never go, allow open any section, never, ever.
Why I asked whether you were still working is I'm gonna show our recording to my son, who is an operations training supervisor at one of the local nuclear plants.
Oh, good, yeah.
And he's working on his master's in systems engineering with a focus on project management,
Mhm.
which I just heard today that AI is gonna take over project management, so he may not have a lot to do. No, I'm teasing.
I know we got a
Yeah.
lot, you know, and will be managed by an
Yeah.
AI agent.
AI bot, yeah. But I want him to look at this and be able to consider his plant. Because there was a recent issue at one of the other nuclear plants. I don't know if it was in the same company or just nearby, that had some issues that came down to operator misguidance
Mhm.
or misdirection or,
Misinterpretation, whatever.
Yeah. and so I want to approach him by that and say, if you're looking for a possible, what are the PAC meetings go and look at for your graduates?
Our program advisory committee, what?
Yeah, when we go and we review their,
Like the course objectives?
no, at the end of the year when they do
All the
their
capstone presentations.
capstones.
Yep.
I don't know if a master's degree program in systems engineering is gonna have a capstone or if it's gonna have a thesis. I don't know. But I'd like him, if he's gonna do a project management approach, that he could put together how to use his system, and they've got an operation system simulator. And they could begin looking at improving their operator interfaces with something like what you're recommending here.
Mhm.
And then if they needed some review or guidance, or I could give them your card. If you have card, I'll trade with you. Or are you on LinkedIn?
I'm on LinkedIn.
I'll connect with you on LinkedIn.
That's even better.
Mhm.
Thank you, Lothar. Yeah,
No, I always answer on LinkedIn, so use LinkedIn, that's fine.
super, most excellent. And it's okay if we call you Doc,
Whatever.
L squared,
That's good, yeah.
fabulous. We love these things. Thank you for Jonathan for ropes this guy in and.
No, thanks, that was your the invitation and yeah, I'd like to talk about HMI, so. Cause it's a passion and
I'm just embarrassed that I worked on all of those examples. I mean, the really garish ones, with the big graphics. And,
And so have I.
yeah, I know. I want to tell you some of them.
I still run across some that were designed 20 years ago that are still in operation, that the background is black. And
Yes,
there's so much color there, you can't tell what's going on.
yeah, I still see those too,
You know, we won't mention companies that have those.
I have
Or the.
one question. I know in any building where you've got lots of piping, they like to color code them.
Mhm.
And a wastewater, same thing.
Yep.
And so they like having those pipes color coded as well.
In this.
But in your description, you said it's best not to do that.
it's best not to do that. So in the plan, I fully understand. I would encourage to the pipes in the plant, like, okay, this is steam, this is water, this is ammonia, whatever you have.
Yeah, all of that.
Yeah, exactly,
And,
water return.
But not on the operator screens. Okay?
Okay.
Because like I said, color is distracting, it's
Yeah.
may you confuse. Color has a dedicated purpose. That is indicating an abnormal situation. A steam pipe is not an abnormal situation, just because it's in steam color. Being highlighted, so that's the idea, okay? Only use color to indicate something needs attention or is in abnormal situation.
Or if you do very minimally, like sometimes what we've tried to do is make it very muted.
So
Light.
sometimes I had this discussion with some operators where they think a certain line is very important to understand that this is the line for just in nitrogen kind of sparge, whatever. So, okay, if you really want that to be different, then you can talk about different grayscales and stuff like that. But no color, please. And that was accepted actually, not in that specific case, yeah.
And I know it is only one slide, but that, what you said about the control room experience, depending on how long your shift is so critical.
Oh, yes. Yeah.
Because where I work now, you always have to have someone there. And you have their overlapping shifts.
Yeah.
And it's basically their home away from home. So you have to make it definitely very well lit. Give them some sense of time, so they
Correct.
have this little thing where the lights overhead will change when it's nighttime versus daytime, so.
Sometimes you can do that, yeah, why not? There's no objections if you want to do it.
You know, it's all very subtle, but it gets them so they can get around, and because it's designed well.
Yep.
They don't have to be glued to the screen the whole time, they can get up, walk around, and they can always be looking, and there's signs saying. Don't always stare at that, stare at other things once in a while.
And that's all human factors, right?
Yeah,
It doesn't necessarily have to be associated with the HMI, but it is, right? Because it's the environment.
it's in my.
That's a great thing.
Yeah.
For where you work, John.
Yeah.
Yeah, that's great.
And you need that buy-in from management and.
Yeah, you need to buy in from management, that's right. So it's important that you talk to management from the beginning and highlight these things as well, not just the operations team, but the management.
Yeah.
But you gotta be careful with that, because if you do too much of those recommendations, they get picked up. Next thing you know, you'll be manager.
Bring it on.
Bring it on. Oh, boy.
Too late.
Oh,
I think that's a great job, Lothar.
Thanks.
Can we give him a round of applause, maybe? I'm gonna stop the recording just for the sake of, we'll
Yeah.
publish this on
yeah.
YouTube.
Well,
and-
what about the people online?
Well, they're still on. I'm gonna stop the recording.
Yeah, the recording.
Yeah,
Yeah.
yeah, they can stay online.
One thing I've seen, because I still do support with 3M, is that there'll be an old operator system that's been there for 20 years. They want to upgrade it so it's